We've been scanning deep space for threats, but the deadliest asteroids may not be out there. They may be hiding right next door. Venus, our brilliant neighbor, shelters a dangerous secret, a swarm of giant Trojan asteroids, each locked in a cosmic parking spot, orbiting with Venus but shielded from Earth's view by blinding sunlight. Every one found so far is big enough to wipe out a city, and their orbits can suddenly turn chaotic, sending them careening toward Earth before we even spot them. If Venus really is hiding killer asteroids from us, why has science only just begun to notice? And how many more could be lurking right now? Picture a spot in space where gravity and motion perfectly balance. An invisible parking lot, if you will. 60 degrees ahead of Venus in its orbit, and again 60 degrees behind, sit these cosmic sweet spots known as Lagrange points. Here, the Sun's massive pull tugs one way, Venus's gravity tugs the other, and the combined forces, plus the push from the orbital motion, cancel out. Any asteroid that finds itself at one of these locations, called L4 or L5, isn't drawn toward Venus or flung off into space. It just hangs there, locked in step with the planet, tracing out the same path around the Sun, year after year. These points only exist where the mass ratio is right. Venus is tiny compared to the Sun, but the Sun outweighs it by more than 400,000 to 1, easily passing the 25 to 1 test. So in the Sun, Venus system, these pockets are open for business. Asteroids that drift into these zones can stay put for a while, cradled by a balance of forces that's about as stable as it gets in the inner solar system. From Earth, though, those asteroids are hidden, their orbits perfectly synchronized with Venus, always just out of reach. Jupiter is a magnet for asteroids. Over 10,000 Trojans have been found riding ahead of and behind the giant planet in its orbit. These cosmic hitchhikers are so common around Jupiter that astronomers have started naming entire families after characters from ancient epics. Now, compare that to Venus. Despite having the same kind of gravitational parking spots, Venus has only about 20 confirmed co-orbital companions. It's a tiny crowd, more like a private club than a bustling stadium. Each one moves in lockstep with Venus, sharing its year-long journey around the Sun, perfectly matched in orbital rhythm. So why the empty seats? Is Venus just pickier about her company, or are most of her asteroids simply out of sight? The numbers raise a question. If Jupiter can host a swarm, what's keeping Venus's guest list so short? And what might be hiding in the glare? Orbits that look steady from a distance can unravel into chaos when you zoom in on the math. Venus's co-orbital asteroids don't follow tidy clockwork paths. Their trajectories twist and shift under the combined pull of every planet, not just Venus and the Sun. Simulations show their fates are sealed by what's called the Lyapunov horizon. After about 150 years, even tiny uncertainties in their starting position balloon out, and predictions become useless. That's not just a theoretical headache. These asteroids can slip from safe, synchronized orbits into ones that cross Earth's path, all because of subtle nudges from planetary gravity or even sunlight itself. Sometimes their minimum orbit intersection distance with Earth shrinks dramatically in a matter of decades. It's a gravitational roulette. An asteroid that's harmless today could, with the right push, become tomorrow's city killer, and we'd have no way of knowing until it's already on the move. A 140-meter asteroid doesn't sound impressive until you do the math. At typical impact speeds of 20 kilometers per second, a rock this size carries more than 200 megatons of kinetic energy. That's not a typo. The blast would dwarf the largest nuclear weapon ever tested. For scale, The 1908 Tunguska event in Siberia, which flattened over 2,000 square kilometers of forest, was caused by an object only 50 to 60 meters across. A Venus co-orbital at 140 meters would deliver energy 4 to 5 times greater, enough to erase a city and devastate the region around it. Most of Earth is empty, but a single strike over a populated area could mean millions of lives upended in an instant. Early warning isn't a luxury. It's the only thing standing between a near miss and a catastrophe. These are the stakes hidden in Venus's shadow. When astronomers try to hunt for asteroids near Venus, they run headlong into the sun's blinding glare. Venus hovers close to the sun in our sky, never more than about 47 degrees away, so ground-based telescopes are forced to look at awkward angles during twilight. That means they're peering through thick, turbulent layers of atmosphere, fighting both the fading light and sky glow. Most survey telescopes refuse to risk their optics anywhere near the sun, so anything hiding in that zone is effectively invisible. The result? A permanent blind cone where city-killer asteroids could lurk for years, undetected. Astronomers know these gaps exist, and it's a source of constant frustration. They get only brief, low-quality glimpses during dawn or dusk, and that's nowhere near enough to track fast, faint objects on unstable orbits. Until new technology comes online, those asteroids remain hidden, shielded by nothing more than sunlight and bad timing. The Rubin Observatory is about to change the rules. With its giant camera scanning the sky every few nights, Rubin could double the number of known asteroids in just 6 months, a pace that took all of humanity 2 centuries to reach before. This isn't just about numbers, it's about catching what's been slipping past us. For the first time, we'll be able to fill in the blind spots and spot threats hiding in plain sight. The future goes beyond waiting for rocks to cross our path. With projects like Crown, the plan is to watch from all angles, building a true planetary defense system that looks outward, not just inward. Instead of hoping for luck, we're moving to active vigilance, mapping, monitoring, and preparing for what's out there. Of the more than 10,000 Trojan asteroids found near Jupiter, only about 20 have been identified in Venus's orbital path, each over 140 meters wide, large enough to cause city-scale devastation. The documentary revealed that these objects linger at Venus's L4 and L5 Lagrange points, where gravitational balance can temporarily shelter them from detection. But simulations show their orbits become unpredictable after about 150 years, and some could drift toward Earth. Despite advances like the Vera C. Rubin Observatory, which will scan the entire sky every few nights and is projected to double the known asteroid catalog within 6 months, a significant detection blind spot remains due to the sun's glare. Key questions endure. How many more hazardous asteroids are hidden near Venus? When will we find them? As of today, planetary defense strategies must look beyond Earth itself, toward the inner solar system's overlooked corners. The evidence is clear. Vigilance, new technology, and international cooperation are vital in tracking what Venus might be hiding.